Let's see.
All right. Developing data exchange pipelines. This module, developing data exchange pipelines, is designed to equip you with knowledge and skills
Wait
necessary.
a second. Test.
Check, check, check.
Yes. Okay. Everything is working. Chalo. All right. Let me recap first before we start. Um. So we have completed 6 out of the 8 modules for the Learn OpenUSD and the OpenUSD certification. We are on our 7th module today, and let me see if I have updated it for yes, module 7. And we are going to be completing hopefully both of these modules this week, and then all we are going to do from next week is practice.
Yeah,
That being the questions and the practical implementations by creating, multiple projects, and really getting the OpenUSD, you know, fundamentals and basics, and everything fundamentally clear, and actually gaining the depth and knowledge of this beautiful technology. And so yeah, without any delay, let's get started on the 7th module. So, developing data exchange pipeline. As Alt already read over here, this module, developing data exchange pipelines, is designed to equip you with the knowledge and skills necessarily to effectively implement data exchange processes using OpenUSD. Data exchange processes being the key word over here. Throughout this module, you'll explore the fundamental of OpenUSD data exchange. Okay, learn techniques for data extraction and transformation, and gain hands-on experience in asset validation. I don't know what asset validation is yet, but I think this is what we're going to learn in this module. So this interoperable nature of OpenUSD is what allows you to leverage your existing 3D tools while developing data exchange pipelines, enabling seamless integration of OpenUSD workflows into your current production environment. Okay. So, interoperable nature of OpenUSD is what you leverage, allows you to leverage your existing 3D tools while developing data exchange pipelines. Okay. Enabling seamless integration to OpenUSD workflows into your current production environment.
hmm.
So, over here, what do they mean by current production environment?
Wait. This interoperable nature of OpenUSD is what allows you to leverage your existing. I think current production environment is, I think, anything that you are working in, that you are
Wow.
on already. Like
I know,
say
bro, but
say you have a very large service or a very large render that is you're trying to do, and you want to integrate OpenUSD workflows into it. Like, because apart from OpenUSD, there are other ways you can render things using Blender and Unreal Engine, right? And I think this is what they're talking about, that this interoperable nature of OpenUSD, it is what allows you to leverage your existing 3D tools. So what 3D tools we have? Blender, Unreal Engine, while developing data exchange pipelines between them. So, and with the help of this, it enables seamless integration of OpenUSD workflows. So whatever workflows you have, you can directly patch it in into your 3D tools that you're using, and into your current production environment. That would be whatever 3D tool that you are using, such as Blender,
Mhm.
and
Mhm.
what other we do here, Unreal Engine, right? Uh,
Yeah, over here. So, like, if you're using Maya for modeling, Houdini for effects, and Unreal Engine for rendering, that is your current production environment.
yeah.
OpenUSD seamlessly plugs right into the middle of them so they can all talk to each other. Hmm. Okay. Nice. I understand the picture a little bit now. Yes. Okay. This module is designed for those with experience in 3D graphics and OpenUSD, providing you with knowledge and skills to effectively use OpenUSD in your workflows and improve interoperability between different 3D applications and formats. We encourage you to actively participate in the exercise and quizzes to enhance your learning experience. Okay. Hmm.
Learning objectives. By the end of this module, what we will be able to do: define key concepts related to OpenUSD data exchange, explain the challenges associated with data exchange in OpenUSD, implement basic data extraction technique for geometry and material using OpenUSD, assess the quality and validity of OpenUSD assets using the asset validation technique, develop a functional data exchange pipeline that incorporates extraction, transformation, and validation process for OpenUSD assets.
Hmm.
Right.
This module contains the following lessons: overview, setup, data exchange, data extraction, asset validation, and data transformation. Prerequisites: completion of the lessons in setting the stage, scene description, blueprints, composition. Yeah, basically all the previous six. Create composition, composition basics, 1, 2, 3, 4, 5, 6. Yes. An understanding of fundamental programming concepts in Python 3, such as functions, loops, dictionaries, and arrays. Bro, dictionaries. They are saying you need to know dictionaries,
Yes.
not
But
JSON.
not talking about nested dictionaries. Do not
Not
despise.
they are not talking about JSON, just to be clear. And arrays and Python 3 related libraries. Understanding of OpenUSD concepts and basic OpenUSD APIs, yes, tools and libraries, blah blah. Okay. Setup. Okay, another data exchange. Mm-hmm. In whether USD data exchange. Shapes. Bro, there are only two files in this.
Well, let's see. Well, I think it's a really. Oh yeah, I think they are only trying to showcase how we can do data exchange between two tools, right? That's why.
Oh, I see.
Yeah, let's see what happens. Let's go.
Open the folder, root folder for OpenUSD binaries. We named the folder USD root when installed, blah blah blah, la 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 la. Copy the extracted folder into USD root by dragging, blah blah blah. Yes, okay. If you have set up virtual, blah blah blah. Okay. Data exchange. Data exchange. Let's get started with the first lesson in this module. In this lesson, data exchange, we will define what OpenUSD data exchange is, learn the various ways a converter can be implemented, outline the anatomy of converter in Python, understanding the challenges of writing a converter. So we are basically gonna create a converter over here. Various ways a converter can be implemented, anatomy of converter, and understand the challenge of writing a converter. Okay, here's an outlier outline for this lesson. What is data exchange? Anatomy of a converter. All right. What is data exchange? Brief review. What is OpenUSD? Okay. Common data models for 3D interchange. Universal theme description. Common data models for 3D interchange. Before we get started with the lesson, let's briefly review what OpenUSD is and how it relates to data interoperability and data exchange. OpenUSD is commonly referred to as USD, which stands for Universal Screen Description. What makes OpenUSD universal? OpenUSD was developed by Pixar Animation Studio to address the complex 3D workflow challenges common in assembling and animating virtual worlds, where dozens of studios and specialties have to come together and collaborate on a single 3D scene. Okay. To solve this problem or these problems, Pixar built USD with a core set of schemas to effectively describe 3D scenes, including meshes, materials, light, and cameras. Okay, these data models describe many of the elements you would need to be able to make a 3D scene, such as those seen in an animated film and have been used successfully by many studios as common interchange format to pass the data between applications. It gets better. Okay, OpenUSD also can extended with new schemas to describe the data models for any domain, including physics, robotics, synthetic data generation, and more. Yes, here we go. Whew. OpenUSD was designed to be able to interchange data between digital content creation software, first for media and entertainment, but now for all industries. What do we mean by data exchange? When we talk about OpenUSD data exchange, we are asking how do I get my data into USD and how do I get my data out of USD. We may want it out in the same format it came in, or we may want it in a different format. For example, we could import STL asset and export it to GLTF. I don't know what that is.
Mm-hmm. GLTF is a file format, I would say.
I know both of them are file format. We also want to discuss what kind of implementations exist or can be developed for translating between OpenUSD and other data formats. Okay, STL is stereolithography and GLTF is GL transmission format, often called JPEG of 3D. Oh, GL transformation format. Unlike STL, a GLTF file uh, packs the complete package. Oh, okay. So when last, okay. We also want to discuss what kinds of implementation exist or can be developed for translating between OpenUSD and other formats. Lastly, effective data mapping must be part of the that conversation. For example, we could model a neural radiance field as polygonal mesh in USD. Is that the best way to import our NERF? Probably not. So we should discuss these issues and what does this mean, bro? This paragraph.
Wait, I was still looking at over there, but we also want to discuss the kind of implementation exists or can be developed for translating between OpenUSD and other data format. Lastly, effectively data mapping was a part of that conversation. For example, we could model a neural radiance field as a polygonal mesh in USD. It is the best way to know. I don't know what is first of all NERF, and probably not. We can discuss these issues if they arise and see if we should develop a better way to model our data. What the hell is this? And yeah, field neural radiance field into a mesh.
The translators. Here is what is meant by in plain English. We need to figure out what kind of software tools like plugins, export, buttons, background scripts we can build to usually convert a other 3D file types into OpenUSD and vice versa. Oh my god, why do I always get that sleeping wave, bro?
Nerves excel in producing what? High detail and realistic 3D representations by learning and representing volumetric scenes with continuous radiance field, capturing fine details and complex lighting effects that photogrammetry may miss. Ah, but this nerve is something different.
Uh-huh. Hmm. Whew. Give it 2 minutes. Can you
Mhm.
search on this?
Yeah, I'm looking into it. Mhm.
Right. So, what did you find?
Yeah, wait. Yeah. Where was it? What the hell? Yes. So NERF is basically an AI way. That is the simplest explanation I'm gonna give you. It's a really complicated thing, but the most simplest explanation. It's basically an AI way to turn bunch of flat photos into something
Mm-hmm.
that behaves like a 3D scene. So you can look at
What is the full form of
it says over there neural radiance.
neural radius
Yeah,
radiance field?
yeah. So something that behaves like a 3D scene. So for example, you have you seen any how would I say any app that scans an object and then gives you a 3D visualization of that object,
Mm-hmm.
right?
Yeah.
So so that app uses nerve, that is neural radiance field, to create a
Mm-hmm.
3D scene of that object, right? And once you have
Mm-hmm.
that 3D scene, you can apply the polygonal mesh onto that 3D scene to do like whatever changes or whatever, pick up the coordinates of that object to apply your
Mm-hmm.
and all those things. So this is what nerf is and how we are going to use nerf with OpenUSD eventually. So I think it would be like you scan an object, nerf converts it into a 3D scene, and once you have converted it into a 3D scene, that
Mm-hmm.
it will have polygonal mesh, right? That will be like the coordinates and vertices and all those things. And once we have that,
Mm-hmm.
we can do other changes that we want using our composition arcs and other things that we learned till now.
Mm-hmm.
Like that is the most basic explanation. Like if we go deeper, then that's a different thing. I don't want to take
Mm-hmm.
it away.
So we need to figure out what kinds of software tools, plugins, and blah 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 we can build actually to convert 3D files types into OpenUSD file and vice versa. Just because we can convert data doesn't mean we are doing it right way. We have to be smart about how we reorganize the information. The analogy: imagine taking a beautiful high definition bokeh video and converting it into a physical flipbook of printed picture. Unlike you, the translated the visual data, but in a terrible, but is a terrible, inefficient way to watch movie. Okay. Similarly, the text points out that the forcing a complex glow 3D volume NERF into basic hard 3D shell polygonal mesh or just to get into OpenUSD, it is a bad idea. Oh, we need to actively discuss and design the absolute best, most efficient way to store data so it doesn't lose its rules, lose its true form, or slow down the computer. Okay, got it. Lastly, effective data mapping must be part of conversation. For example, we could model neural radiance. There are four common implementations for adding OpenUSD support for your data format.
For application, importers, exporters, standalone converters, and file format plugins. At a high level,
Okay.
whether your data is represented as a file format or runtime format can dictate the type of implementation. But there are other factors to consider as well. Importers and exporters. You may have experienced an importer or exporter in the past via file import or file export menus to
Yeah.
clarify inputs and outputs for our purpose. How translate data from OpenUSD at runtime format of the application. Exporters translate data from runtime format of the application to OpenUSD. Yeah, that's pretty straightforward. These are implemented as a part of digital content creation DCC application for translating to and from the application's runtime. Depending on the application, it might be native feature of the application or implemented as a plugin. Plugins might take the form of first party or third party development. Standalone converters. A standalone converter is a script, executable, or a microservice dedicated to translating to and from another file format. Oh, okay. So it's only it's this convert standard and alone converters are only dedicated to do one thing only. That is either to transform one format to another. Yeah, we have file format X, and then that's our standalone converter, and it's going to convert it to OpenUSD. Unlike
Mhm.
importers and exporters that have clear translation directionality, a converter could be one way or two way. It's important for developers to document what their converter does. File format plugins. File format plugins are unique features of OpenUSD. They allow OpenUSD to compose the additional file formats and even non-file based sources such as databases and procedurally generated content. Here are some key points about file format plugins. What do we have? An open source stage can include a source file directly.
OpenUSD stage, bro.
Yeah, OpenUSD stage can include a source file format directly as a reference, yes, payload or sublayer. We know that. The source file format is translated on fly, okay, while it is read as a USD document layer in USD parlance. The file format can remain the source of truth.
Mm-hmm.
File format plugins can be bidirectional, supporting both reading from and writing to the source file format. And lastly, they can be used as standalone converters with tools like USD cat. Wait, I think we did write
Okay.
USD cat somewhere, right? USD cat.
Oh.
Write files. Oh, USD cat. Oh, okay, okay. That's normal. Right, wait. What is the difference between USD cat and USD edit versus USD
Mm-hmm.
edit? So it's like basic cat command that can edit. Reference world. Okay, the functionality enables seamless integration of various data sources in OpenUSD workflows, allowing for greater flexibility and interoperability in 3D content creation and management. USD CAD is mainly for printing or converting USD file or edit is opening. Okay, okay, okay. Just can use for standalone converter. Challenges. OpenUSD's flexibility and modularity make it suitable for wide range of applications and industry. These features and its universality make the challenge of data exchange very apparent. Data exchange is typically lossy. Not every data model can be mapped directly. Not every consumer may be interested in all the data exported via digital content creation tool. For example, a CAD application may not need animation data. Okay. 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 The content exported by DCC tool may not be suitable for every organization and its workflow. There is no single content structure suitable for all end clients, and organizations. And lastly, not every client can handle the same content fidelity. Example, high quality offline renderer versus the real time 3D app on a phone. So these are some of the challenges we might face or someone might face when they're trying to export OpenUSD file for into other tools as shown. Now, next is two-phase data exchange. To help with these data exchange challenges, we propose a two-phase approach: extract and transform. This is loosely inspired by ETL, used in data analytics and machine learning. By following two-phase data exchange approach, your implementation will solve many of today's exchange challenge and help you serve the widest range of customers. Data exchange to OpenUSD should start with extract phase. The goal is to translate the data to OpenUSD as directly as possible to maintain fidelity to the source format. Try to map concepts from source format to concepts in OpenUSD as much as possible.
Mm,
Integrity and structure of the source data. Oh, okay, okay, okay. So yeah, it's a more of a ETL pipeline, and we will be mapping most of the formats into OpenUSD as much as possible. But we might lose some context as well. That is the drawback of a ETL pipeline.
mhm.
The transform phase consists of one or more optional steps added to better meet end client and user needs. Applying user export options, making changes to the content structure that deviates from source format, and implementing optimizations for better end client and workflow performance. Lastly, we have OpenUSD Exchange SDK. OpenUSD Exchange SDK helps developers develop their own USD input output solutions that produces consistent and correct USD assets across 3D ecosystems. It provides higher level convenience function on top of lower level USD concepts, so developers can quickly adopt OpenUSD best practices when mapping their native data sources to OpenUSD legible data models. All of the concepts in this model can be applied to working OpenUSD Exchange SDK. Oh, for developing data exchange implementation. Oh, okay, okay. So all in all, whatever we have read till now is already gonna be in the OpenUSD Exchange SDK.
Mhm.
Oh, okay, okay. So I think we might have a hands-on exercise with this as well.
Mhm. So what was it trying to say with
Which
the whole thing?
the whole thing was showcasing us everything that what OpenUSD data exchange looks like. What are the challenges we might face when we're trying to transfer data from one source to another, and how what are the things that OpenUSD use. Like there are importers and exporters that act as one-way directions that convert
Mhm.
OpenUSD into a file type that they understand using basically the DCC that we read, and
Mhm.
then it showcases some of the challenges we might have when we load or export data from OpenUSD into some other tools, just CAD, actually, as it says over there where you are highlighting right now. And uh, and the other thing was maybe some of the content is not suitable for every organization and its workflows. So
Mhm.
these are some of the drawbacks or challenges we might face.
But
And
mhm.
and the
Okay.
most important thing was a two-phase data exchange, like creating an ETL pipeline that you are continuously extracting data from a source and then converting and mapping it into a format that OpenUSD accepts. And once you have done that, then you have basically created a data pipeline that converts. let's say you're picking up data from CAD that converts CAD data into OpenUSD,
OpenUSD.
and then you can render those things accordingly.
Mm-hmm. Okay. Huh. And then there are two phases for data exchange. One is extraction, one is
Yeah.
transformation.
Extraction, transformation, and then loading.
Okay.
Yeah, like that's how typical ETL works: extract, transform, and load. So once you extract it and then transform, then you load it into a file or something.
Following this two-phase data exchange approach, implementation will solve many of today's exchange challenges and help you serve the wide range of customers. Help you serve the widest range of customers. Data exchange to OpenUSD should start with the extract phase. Goal is to translate the data to OpenUSD as directly as possible to main fidelity and source format. Try to map concepts from the source format to concepts in OpenUSD. What does this mean?
Which part?
The goal is to translate data to OpenUSD as directly as possible to maintain fidelity. Oh, okay, okay. Never
Like
mind.
trying
Try
to
to
map
map.
concepts from source format to concepts in OpenUSD. Like it's not necessarily that you will map out everything. Like there might be some of the things that might be missed out, right?
Mhm,
So, but the goal is for an ETL pipeline to map one is to one, or map
mhm,
out the most relevant information that is transformable into OpenUSD, and so that OpenUSD can understand it and render it accordingly. Like less data loss.
mhm. The transform phase consists of one or more optional steps added to meet end client and user need. This includes applying user export options. Okay, making changes to the content structure that deviate from the source format, implementing optimizations for better end client and workflow performance. The transforming phase consists of one or more optional steps. Okay, so applying user export options, making changes to content structure that deviate from the source format, and implementing optimizations for better end client and workflow performance. Okay, okay, transform phase. OpenUSD Exchange SDK helps developers design and develop their own USD input output solution that produce consistent and correctness USD assets across diverse 3D systems ecosystems. It provides higher level convenience. Uh, Come on. It provides higher level convenience functions on top of lower level USD concepts. So developers can quickly adopt OpenUSD best practices when mapping their native data sources to OpenUSD legible data models. Okay. So where is extraction? Okay. Hmm. Hmm. The workflow structure exported by DCC tool may not be suitable for every organization. Workflow is no single content structure suitable for all end-to-end clients. Not every client can handle both the same content fidelity, high fidelity offline render versus real-time 3D render, 3D app on phone. Okay, okay, got it. Next exercise. Anatomy of converter. Let's create a Python script to house all our code. We'll be developing a standalone converter to help understand how a converter works. Create a Python file. This. Oh, we are going to be creating this ourselves now in the data exchange folder. Okay. So obj2 usd dot py. OBJ2 USD. Next, we'll add some boilerplate code to help you get started. The following code is the straightforward starting point for coding the different parts of the converter. What was exactly the converter? The
Like write your own converter, like you're basically converting any format into
All right.
what? It's like a literal thing.
Mm-hmm. When you write your own converter, the specific structure isn't necessary. Uh-huh. Mm-hmm. At the top of the file, important statements provide more interesting information. We'll use assissim open asset import library. Oh, okay. Mm, Open asset import library, an open source file format conversion library to parse OBJ files for us. We are also importing the USD Python API for USD authoring. If name equals to main section towards the bottom of the file is the entry point of the script. Ah, I see. Mm. Note that the script processes a few command lines in argument. Bro, what the fuck is happening? My eyes.
Just open up the experiment, right? Like you open up the
Yeah.
experiment. Yeah.
Okay. Now I'm just trying to see. I have already opened the experiment and I've also added the code over here.
Mm-hmm.
Uh, takes the input object file path to convert an output an optional output path for exported USD file. If not supplied, it will use the OBJ file path with a .usdf file extension. Oh, so this is creating a converter. Mm, where's the extractor?
Yes.
What?
What? So we have opened up the file. Let's go through the file. We have two enums. All right. So we are gonna add the code over here. So okay. We are gonna create an object USD file, as we can see, and once we have the object to USD file, we're gonna add state extract. Okay, we're gonna use extract. Where is the extract coming from? Okay, there is no function. Oh, we are gonna create a main function that does that. Okay, okay. Argument input, argument output, and then this is the extract function logger.info. Then we're gonna use dot import file. What is this one? Let's see.
One second, I'm coming.
Come on.
Fuck, dude, I'm so sleepy today.
Throw some chilled cold water on your face.
Oh. Whew. Okay, let's quickly read this again. All right, we are basically adding a converter now. This converter, what is it doing? It's basically going to convert an object file into USD, I guess.
Mhm.
And now we'll add, okay, next we'll add some boilerplate code to help you get started. The following code is the starting point for the coding the different parts of the converter. When you write your own converter, the specific structure isn't necessary. hmm So what are they doing? They have two enums. Okay. Then okay, they ask us to add the main function over there. What is the main function doing? At the top of the file import statement provided some interesting information. We will use async, open asset import library, and open source file format conversion library. So this is an open source file conversion library, async dot underscore py. Okay. Then open blah blah blah. To parse obj files. What are obj files?
Object files.
Oh wow. Wow bro, wow.
Oh.
But what is the data inside these object files,
That
bro?
we
That's
don't know,
my
right? That we don't know. That is what we are trying to parse.
if name main section towards the bottom of the file is the entry point for the object to USD script. Note that the script processes a few command line arguments. Okay, so this is the it's like a management command over here.
Yeah.
That's gonna oh now I get it.
Mm-hmm.
This is the object file that they have provided. So this is like a Blender file, I guess.
Yeah.
You see Blender 4.04
Yeah, so
alpha.
this is where we are trying to create a data exchange pipeline that we are
Mhm.
trying to render, take input data from somewhere and then output it into OpenUSD format using
Mhm.
simp underscore py. That is what was it?
Open source
Import library.
object conversion library.
Oh yeah,
And then, so the main function, what is the main function doing over here? So take input, output, exported USD file. If not supplied, it will use the obj file path with a object.usda file extension. Up access and export option to control what up access for the export USD state should be. Once the arguments are passed, we call main. However, main does not exist yet in the section below code. Okay, so this is main. Left main arguments are parse namespace. Okay, so stage is usd.stage extract args.input and args.output. Okay, and then transformations to be applied to the scene hierarchy. Transform stage comma args and stage comma save stage dot save. So USD stage equals to extract, and what are these two arguments over here? Input and output.
so like arguments, you will pass on them. You are basically creating a main function. And
Yeah.
if you go down, like there is an extract function over here that is going to take those,
Yeah. Mm-hmm.
right?
So now we are
So those
okay. So
arguments we
now
are
we are
getting
just using
from,
extract and transform functions over here,
yeah,
but we are going to be defining the extract and transform functions in the below. Okay.
yeah.
Referring back to the anatomy of a converter, we start with the extract phase to map the data into OpenUSD as directly as possible to maintain fidelity to the source format. Then we will be performing a transformation phase which consists of one or more optional steps that are added to better meet and client and user needs. For this module, we'll focus on the following: applying user exporting options, making changes to the content structure that deviates from the source format. Okay, let's start with defining extract and above main. So this will be above main. Hmm. Okay, and then what is it doing? Basically, input file argument path, and then output file is path
Yes.
to USD stage.
So
Hmm.
like yeah, these are the two arguments we're taking in our extract functions that we are will
Hmm.
be sending what is the input file that we're taking and where will the output file be generated.
Hmm.
Right, that is the file path, and then we are going to use a simp
Hmm.
underscore py dot import file argument function to basically input the file and with the process flags that we are going to use, which is 0. And once we have
Uh-huh.
that, then we are going to create a stage with the output file that we have generated.
Load the object using asm scene equals to a simp py dot import file string input file process flags. Okay, so process flags would be this one.
Yeah.
So both of them will be the argument for this function sm py dot import file,
Hmm.
and then based on that it will be saved in the scene. And then stage usd dot stage equals to usd dot stage create new and string output file. Okay, return stage, and then above main add the following code. So you'll notice we are not parsing through the scene data we got from a sim. Mhm. In the next module, we'll go over how we extract the geometry of our object file. Mhm. Okay, so we have transform as well now. The last piece of our two-phase approach is defining the transformation above main. Okay, so it is taking in USD stage, and then what is it doing? Also taking in args parse dot namespace. What is this?
Name. So the thing is, in Python, you when you are trying to create a custom function, you can pass on an argument like whatever name you want to pass based on the namespace that you have created.
Mm-hmm.
This dot namespace is something that you might have created earlier somewhere else, right?
Uh-huh.
So the stage will be the default function that you will be passing on, but this arg, like, it can be anything. You can pass any name, you can pass whatever you want at this point. So this is like a free. You can pass any number of arguments into this, so that, like, those are
Mm-hmm.
like optional arguments. It's not necessarily that your function should take it, and but your function should at least need you need to, when you're passing it, you need to make sure that you are passing stage, right? Otherwise it's not going to work. But if you do not, if you pass any other thing apart from stage, it will still take it, because
Mm-hmm.
that is the extra argument for.
Okay. So at this point we have outlined what, wait, what did you say? Extra argument for? It will still take what?
So when you define this function, right, you have two things:
Mm-hmm.
stage and the extra argument that you want to pass on, that can be used later. That's what it is talking about. So when you say transform stage, you can still pass it. It's gonna take it. But if you pass an extra one, it's not gonna throw an error.
Uh-huh. Oh.
Yeah.
Hmm. At this point, we have outlined our two-phase process. The hierarchy is currently defined as main, extract, transform, and then object from object and convert into USD, where we apply export option and transformation to the content structure that are not part of the original object file. What? Why is it? How will it not be part of the OBJ file?
When we apply export option, any transformation to the content that are not part of the original OBJ file. Wait, the law is defining a transformation. So I think anything that is not part of OBJ file, like missing objects,
Mm-hmm.
maybe that's what it is talking about. So first we extract the details, right? But there might be something that OpenUSD needs that was not present in OBJ file. That's what it is talking about. Like
I know that, but where is that data gonna come from if it's
I
not
think
in
if
the
you
OBJ?
go down, it's going to explain. Like that's
Okay, so
something
it's
that
saying we
I
will not execute the script yet, but we will continue to build upon it throughout the rest of this exercise in this module. Fill out, extract, and transform functions. Oh, so this is just the skeletal of the converter.
Yeah, like they are showcasing us how does ETL works and how you can bring in your data.
So this is what the code looks like up till now. Oh, okay. Data extraction. What is data extraction? Data extraction, we will define benefits of data extraction, examine examples of data mapping, learn how to start data mapping. Here is an outline for this lesson. What is data extraction? Exercise extracting geometry, exercise extracting materials. Oh, oh my god. Okay, you ready?
Yes, sir.
What is data extraction?
Benefits of data extraction. Data extraction offers several benefits. Output USD, output OpenUSD data looks like like it did in the
It did.
in the source format. Oh, okay. Making it easier to understand and debug for developers and users. This is critical for legibility, one of the core principle of scalable asset structure. It simplifies round tripping of data and it provides a common foundation for all data transformation in transform phase. Transient data. The output USD data from data extraction phase is often treated as transient data. The author of an exporter will often choose to not write data extraction output to disk and only output the transform data, which is better suited for end users. Author of data exchange implementation should consider optionally giving access to the in memory. If you go down,
I didn't understand this, by the way. What does this mean? Output OpenUSD data
you read it.
looks like it did in the space source format, making it easier to understand and debug for developers and end users. Okay, this is critical for legibility, one of the core principles of scalable asset structure. Core principles of scalable asset structure. Oh, legibility that we did yesterday, I guess.
Yeah.
Principles of asset structure.
So like basically mapping one to one from your source file to OpenUSD file without losing any data. That is where data extraction comes, and that is the most important thing for over here. And that is one of the benefit it says it's gonna give us.
Output, okay. It simplifies round tripping of data. It provides a common foundation for all data transformation in transform phase. Hmm. Okay. Transient data. The output USD data from the data extraction phase is often treated as transient data. The author of an exporter will often choose to not write the data extraction output to disk and only output the transformed data, which is better suited for end users. Oh, oh, holy shit. The fuck is this, bro? Let me put this in Claude, bro. Let's understand this from Claude. It's too much data.
Hmm.
Mhm. No, let me read this first quickly.
Mm-hmm.
I've given it to Claude.
Okay.
So it's simply blah blah blah. The output USD data from the data extraction phase is often treated as transient data. Okay. The author of an exporter will often choose to not write the data extraction output to disk and only output the transformed data, which is better suited for end users. Of data exchange implementation should consider optionally giving access to the in-memory extracted stage. Hmm. Or writing extracted stage to disk, as it is valuable for third-party developers that may want to write their own transformation steps. Without it, third-party developers may be left to reverse engineer your transformations. Okay. Authors of the data exchange implementation should consider optionally giving access to the in-memory extracted stage. Uh, Examples of transient data from extraction phase that could be useful during the transformation phase include texture and material conversion. When converting between formats like FBX and GLTF, materials or textures may need to convert may need to be converted from one format structure to another. Examples of transient data from extraction phases that could be useful during the transformation phase. Texture and material conversion. When converting between formats like FBX and LTF, materials or textures may need to be converted from one format structure to another. For instance, an FBX material may contain complex shaded information not supported by GLTF. Transient data in such a case may take the form of intermediate texture maps and definitions or color values that help map FBX material to GLTF ones. This data may be disregarded or discarded after conversion or cached in order to be reused for repeated iterations or during development. Uh-huh. Metadata information. CAD files might contain extensive metadata related to manufacturing. Example: PIM metadata about material properties, tolerances, or design notes, which may be relevant for real-time visualization or rendering applications. Hmm. Hmm. Which may not be relevant for real-time visualization or rendering applications. Transient metadata may take the form of filters tagging the information to retain a sidecar file such as JSON, XML, PDF, or Excel containing the annotations originally included in the source file. Huh. Formats such as FBX or CAD may store multiple levels of. Oh, I think this is not that important.
Output data from data transaction phase is often treated as transient data. The author of an exporter will often choose to not write data extraction output to disk and only output transform data. The author of data exchange implementation uh, consider optionally giving access to the in-memory extractor stage or writing the extracted stage or disk. Okay, just read it and then
I read this, yeah.
you read it completely.
I'm here. Formats such as FBX or CAD may store multiple level of detail for a model, as OpenUSD or target output formats do not universally offer out-of-box support for LODs. Specific geometry LOD must be selected by the transformation process. In this scenario, intermediate mesh representations of or LOD selection metadata may persist to disk for use at a later time. I'm not able to understand one thing. Why? What's the difference of storing the data on the disk and the other thing? What's the other option
Where
if
is
it's
the?
not getting stored on the disk?
It's in the cloud. If it's not on the disk, it's
Bro.
usually for caching purposes. That when so I think when you're trying to render a scene, you are composing it, right? And
Hmm.
when you're composing it, then that means that you are basically gonna compute the maths and everything somewhere, right? So compute the math somewhere, and once you compute the maths, where will you store it? You will store it somewhere. Either you're gonna store it in memory or you're gonna store it in your local disk.
Okay, let's see what Cloud has given. This is data extraction submodule inside developing data exchange pipelines. Track the whole track builds one concrete thing, an object to USD converter. To understand extraction, you have to see where it sits because extraction only makes sense as phase one of a two-phase converter. Okay, so this is extraction, right?
Yes, this is data extraction.
Yeah. She told me her name was Billie Jean, and she got to see the fuck, man. Okay. Source, asset, object, FBX or CAD, and then faithful to USD. So extraction, transform is optimized and delivered to USD to disk. In memory, faithful, often transient. What extraction's job is? Extraction reads the source format and produces USD that looks like the source did. A faithful near 1:1 translation, not yet optimized or restructured. The faithfulness is the entire point and it buys three things the page calls out. Okay. Legibility, debuggability, round tripping, clean and foundation. A clean foundation for transform phase. Okay. Legibility and debuggability because the USD mirrors the source structure. A developer comparing the object and extracted USD can eyeball that the conversion is correct. This ties to USD's scalable asset structure principles. Dude, what the fuck is this? Ami hare. Hmm. Here's the explanation broken down into four simple one. Data is temporary. The initial OpenUSD data pulled during the extraction phase is usually just independent stepping stone of the final product, skipping the save. Most export tools automatically discard this raw data from memory, choosing only to save the final and polished version of the hard drive to the hard drive for the end user. Leave a backdoor. It is highly committed to include an option that allows the other developers to intercept and save this raw intermediate data if they want to, preventing headaches. If you hide the raw data, you force other engineers to painfully reverse engineers your pipeline just to build their own custom tools or plugins on top of it.
Shit.
Examples of transient data from extraction phase. Uh-huh. That could be useful during the transformation phase. Okay, what extraction job you actually is? Extraction reads the source from the produces USD looks like source. Data faithful. Yes, I did this. Round tripping, clean eligibility, clean foundation for transform phase. Every later restructuring optimization step builds on the honest starting point rather than on already mangled data. Okay, transient data. The extracted USD is usually transient. Most exporter authors don't write it to disk. They only want to process the transformed output that end user usually want. But the page's real advice is to optionally expose the in-memory extracted stage or write it out anyway, because the third-party developers who want to write their own transformation needs that faithful intermediate. Oh, without that, they are stuck reverse engineering your transformations. Three concrete kinds of transient data. It gives you an example. Example. Fuck. Come on. Okay. Three concrete times of transient data. It gives as example. Hmm. Here the explanation broken down into four simple lines. Different 3D formats handle materials differently. A complex lighting effect in heavy file like FBX might simply not exist in lightweight web file like GLTF. To translate the visual look accurately, the system has to calculate and generate temporary bridge files. To translate visual look accurately, the system has to calculate and generate temporary which feels like newly baked color maps or simplified instructions. These temporary translation files are what we call transient data. Once the final converted 3D model is successfully saved, the computer usually throws these temporary files into trash to save space. Users, so developer actually specifically keeps them for text testing. Once the final converted 3D model is successfully saved. Hmm. Mm-hmm. Okay. Texture and material conversion. Metadata information. CAD files will contain extensive metadata, manufacturing, BI metadata about material properties, tolerances, or design notes, which may not be relevant for real-time visualization or rendering application. Transient metadata may take the form of filters tagging the information to retain or sidecar files such as JSON, XML, PDF, or Excel containing the annotation originally included in the source file. Hmm. Oh, and then level of detail is formats such as FBX or CAD may store multiple levels of detail for a model, and OpenUSD or target output formats do not universally offer out of the box support for LODs. A specific geometry LOD must be selected by transformation process. This is important.
Yeah, I just read through it. I did read through it. Like the level of detail, yes.
Yes, like it is not done out of the box. We need to
Read through it.
basically
As a data speculation kind of thing.
an OpenUSD or target output format do not universally offer out of the box support for LODs. A specific geometry LOD must be selected by the transformation process. So it should be selected individually by transformation process for getting
Mm-hmm.
extracting the data related to the level of detail, I guess.
Mm-hmm.
Oh. Oh. In this scenario, intermediate mesh representations or LOD selection metadata may be persisted to disk for use at a later time. These may carried along the pipeline for downstream use, discarded at the end of the process. Okay, conceptual data mapping to achieve direct and faithful extraction between two data formats. A conceptual data mapping is crucial. This process involves analyzing how many data models from one format to another. You'll find many composite commonalities that makes for easy extraction. Oh my god. Mm. Conceptual data mapping. Okay, here is the explanation broken down into four simple lines. To perfectly translate between two 3D file types, you first need a master plan data mapping to match up their features like a dictionary. Oh, while many basic things translate perfectly, you will often find gaps where the original file has a special feature that OpenUSD doesn't even have a word for yet. Oh. Instead of just throwing that unsupported data, you can invent a brand new official rule or schema to successfully handle it. By sharing that new rule with the community, you upgrade OpenUSD so it becomes smarter and more capable for everyone else in the future. Got it. While many basic things translate perfectly, you will often find gaps. When source formats has compound or grouped data. Oh, what is Claude saying now? Mm-hmm. Conceptual data mapping. Mm-hmm. This is the heart of the submodule. Before writing any converter code, you analyze how the source formats data model maps onto USD data model concept by concept for object to USD not by that mapping is mostly clean. Huh. Hmm. So what is this example? Phew.
We'll just go through the example. Like I went through the example. The example is pretty solid. The
This one.
Yeah, like the example reference is much better reviewed in the below. Like they have explained in a different table. Just go down. That they have a one-to-one mapping of everything. Go down. Yeah, over here. Take a look
Hmm.
at this. So over here, as you can see, the object had vertex, and what did it mapped out to in our
Points.
OpenUSD file? That is going to be points. Then we have
Hmm.
textures. What are they going to mapped out to? Where's
Prim bars.
we have vertex normal. For them, we are going to have normal prim bars normal as grouping. We had faces
Hmm.
that would be mapped out to face vertex indices and face vertex counts. Moving on, we have materials. So we have diffuse color that is going to map out to input diffuse color, specular color that is going to map out to input specular color, and vice versa. So this is like overview of what this data extraction does and how it conceptually maps out the objects from any file onto the format or anything that OpenUSD wants to accept. and that would make it much more compatible without losing any data or any essential information that would, maybe break the rendering or something. When you're trying to render a file that was in obj format into a openusd format into any openusd viewer or houdini or isaac or something like that.
Hmm. Whew. Okay. How data is extracted. Mm-hmm. And what is this example?
That is like a conceptual overmapping or something that you have. So this mapping will be different for each and every file or each and every file format that we are trying to
Mm-hmm.
create. So this is like in the notebook itself, they have said that they're going to explain it much in further more better manner when we move on to the next exercise. So you can, if you want to review it, you can review it. If you want to skip it, that's on you.
What? This one.
Yeah, this file, yeah, this image. This is more of a reference example for developers that hey, this is how the mapping will look like. The
Mm-hmm.
conceptual data mapping, because it's, like some things are not mapped properly. So how is
Mm-hmm.
OpenUSD gonna infer the OBJ files format and everything?
I see. So Claude is also saying here the same thing that V positions is mapped as points, face indices as vertex indices, normals as normal primbar, VTUV coordinates as primbar set, ST, dot MTL materials as USD shader materials. Okay. Commonalities map really cleanly, position, points, etc. Extraction. Hmm. Hmm. Mm-hmm. Let's see what's extracting geometry doing. Now that we have a way to parse the data in our object file, we can start extracting the new information and translating it into OpenUSD. When passing through each mesh in the scene, we need to make sure the mesh name can be used as an identifier or a prim name. Let's add the tool foundation library to our Pixar imports. Now let's add extract method right underneath where we define the stage. Hmm. Mhm.
Uh, there's no
Where we define the stage before call return stage. What?
no party in the club.
Bro, it's a Monday night.
Now that we have parsed our data in our OBJ file, we can extract the information and translate it into OpenUSD. When passing through each mesh in the scene, we need to make sure the mesh name can be used as an identifier or a prim name. Let's add the tools foundation library to our EXR imports at the top of the file. Add transform TF to the list of imports from Pixar, and it should look like this. Okay, all right, perfect, perfect. We're gonna use the OpenUSD Pixar library and import all the packages, transform USD and USD geom. And
Mhm.
then we are gonna add our extract method right underneath where we define the stage. Okay, and before we call return stage. So
Mhm.
meshes, dot meshes. Okay, we're gonna use CS dot and then all right. Based on diagram below, we will extract the vertex indices of the face and number of vertices for each face from the object. Still within our loop, we create another loop to go through each vertex index for each mesh. This allows us to assemble both the face vertex indices, the face vertex count array for the geom dot mesh. Add the following code underneath where we defined it. Okay, object has vertices v1, v2, v3, v4, v0, 1, 2, 3 endpoints, v1, v2 for space one indices, 0, 1, 2, space 1. Oh, okay, okay, both object and node.
Bro, let's just do quiz. I
Okay,
want to do this tomorrow with a fresh mind.
okay, all right, let's do the quiz. That's fine.
I'm not able to understand it today properly.
Yeah, this is kind of complex, so I won't blame it on you as well. Like I'm also getting a hard time understanding this shit. Like
Yeah.
it's gonna take a while. This is not some easy shit.
Mm.
Like if you want to understand it in depth, like how the thing is working, yeah, let's do the quiz. I think it will freshen up our mind. Yeah.
Hmm. What should you use payloads in OpenUSD? When should you?
I think C.
No, not C.
Sorry, D. Yeah, D. When you want to load an asset only when it is visible in the camera, we can because that is one way.
Yeah.
Yes, sir.
UV coordinates typically stored and accessed in USD.
How you
A.
yeah, A as prime bars. Yeah, A would be because geomesh. But how right? Yeah, yeah, it's gotta be A. Yeah, prime bars. Prime bars was the only one that had that. None of them had anything. Oh wait. Maybe attributes of the geomesh prim. Why cannot it be that? Yeah, let's go with A. Yeah, let's go with A. I think A would be more appropriate. Oh, nice.
Yeah. Let me check this as well.
Yeah.
Okay, in OpenUSD, UV coordinates are not hard-coded in core geometry. Yep, stored in primvars. USD traditionally uses ST. The data type that are stored on flat list of U2D. Hmm. How can you get the value of a custom metadata field on USD Prim using Python?
Okay, how do you get the value of custom metadata field on USD Prim using Python? Custom metadata.
Mm, I think it's gonna be
And, I will go with D, but I'm
none of the above.
no sorry. E. Fuck.
By creating separate USD file
But
containing
I
the
don't think
metadata.
there is any method that will help you get the custom metadata.
Bro, custom metadata is still metadata. So if you do get metadata function on that, it's gonna return the
I
metadata.
don't know.
Huh?
No. Can you
Right,
verify?
right.
Can you verify?
Can get custom data.
What? Get custom data, right? It's not get metadata, right?
Let me check. It's saying get custom data, but I think it's saying that. Mm, yeah, it's get custom data by key.
Right. That's why I was because the get metadata won't make sense because it's talking about custom metadata. So that's why I was going with the D option because B was for sure incorrect. But
Mm,
that was also incorrect. If you get custom data from your previous question is likely blank.
mm-hmm.
Be reading official region fact available directly on the box. So get custom data, right? What is the purpose of shade output? It's gonna be A B C D E,
Output of shader that can be connected to other shaders or material inputs. Hmm. What is the purpose of USD shade output prim type? To describe the material properties of shader output. To define an output of a shader that can be connected to other shaders or material inputs. To define an output of a shader that can be connected to other shaders or material inputs. Okay. hmm Is this correct though?
What is the answer?
Your answer.
My answer. That was correct. Okay.
To define an output of shader that can be connected to other shaders or materials. Oh, this is a wrong question.
Oh.
USD shaded output is not a prim type at all.
Hmm.
If a USD shade shader prim like texture reader or color multiplier is a piece of hardware, USD shade output is the physical out jack where you plug in your cable to send the data to the next device. So it's a wrong question.
Oh, it's a wrong question. What is the
Yeah.
correct? Okay, before we dive into shadation, isn't actually it's a specialized schema class that wraps a standard OpenUSD attribute. Oh, okay, okay. In OpenUSD shading ecosystem, and its purpose is to act as output terminal or port of a shading node, allowing you to pass data or rendering signals down the pipeline. And if a USD shade shader prim like a texture read or reader or a color multiplier is a piece of hardware, the USD shade output is the physical out jack where you plug in the cable. Hmm. Okay. Okay. So first of all, it's not a prim type; it's a schema class. All right. Okay. And what about the answer? So, like, does the answer regarding it was correct or not?
It acts as a port sending the color data out. So the answer is USD shade output. Come on, bro. It acts as an output port. It represents out jack on shading node like a texture render or a math node where a single piece of data originates, builds material network, standardize the data. So it's not that either. hmm How do you mark prim as an instanceable in USD? By setting instanceable metadata to true.
Yes, that is correct.
Which of the following is common use for relationships in OpenUSD, defining parent-child relationship between prims in the scene hierarchy, controlling the visibility of objects in to geometry free? I think first. No, it is connecting material to geometry primitive.
Question again, go on. Which of the following is a common use of relationship? We're defining. Yeah, that is no, no, no. That is correct. A was correct. A was correct. Right? They defining the parent-child between trims. I think that was one way, and controlling visibility. I don't know. Like What was the correct answer?
Hierarchy is defined by stage structures, not relationships, connecting
I
a
think
material to geometry primitive.
geometry is a common case. I don't know, dude. Let's see what Gemini says.
In USD relationship is a type of property that acts as a pointer, allowing one prim to target to refer to another prim or property anywhere else in the scene graph without duplicating data. If you are looking at a specific option, the mostly common use case is material binding. Oh, it is right. Correct. Connecting a material to geometric primitive.
Okay, okay.
Material binding. Okay. What is the purpose of USD geomesh primitive in USD? To define material of an object, to represent polygonal geometry, to optimize rendering performance, control transformation, define material for an object. I think C.
Yeah, C would be the most appropriate. Yes,
Yep.
because all of the other can be also an answer. You want to pass
Mhm.
custom per vertex, custom color value for your modeling software to your USD scene. How would you typically do this? By storing data in USD stage metadata, by creating a primware on the USD geo mesh prim, by storing the data in the USD shade material, by creating a new attribute on the USD geo mesh prim. Okay, you want to pass this? Okay. By storing data in USD stage metadata, by creating primware and you want to create custom per vertex data. Wait, okay.
You pass a custom purple text data, example custom color value. For model software was storing the data in a USD metadata, USD geom data by creating a new attribute on USD geom mesh prim by creating primware. Oh, B.
Oh yeah, B would be much appropriate. Primware. Oh yes.
Yes. I think we did this example as well.
Oh yeah.
What is the purpose of payloads in OpenUSD again? Defer loading of a subtree until it is needed.
To yes, A.
Yes, sir.
You
You
want
want to store information about
to
author of USD asset
where would you typically store this information? Metadata. B.
as a metadata on USD stage. How does OpenUSD achieve scalability in handling large and complex scenes? So converting all data into monolithic file now. Recording all assets to be pre-optimized for a specific renderer, maybe by relying solely on in-memory data structures. Complexity of individual assets. C, I guess.
How OpenUSD achieve high scalability in handling large and complex scene? No, no, C won't be an answer. D.
By restricting the complexity of individual assets. Hmm?
Yes, yes, D.
I don't think so, bro.
Only one way
Yeah.
by converting all data into single. Let's
What?
use Gemini.
I thought this was like the worst answer.
Yeah, I thought so. Was I think this is something it might be written in the documentation, and we might have overlooked it.
Oh, maybe in one monolithic file which is called the root layer. No, I don't get it. Bro, what the fuck are you doing?
Nothing, bro. Okay, what it is saying over here, OpenSG was purposed by payloads, crazy, wild, blah blah blah. But where is the answer? Okay, while the standard will load entire asset into active memory, payload act as default references, blah blah blah. Uh, Aggressive instancing spars and create binary. Okay, ask him based on the options we have. What is the most appropriate one? Like, just ask him what. Is this answer correct? Because like we can also use suppose compositions and referencing avoiding monolithic file. I know, yeah, like monolithic file structure could be an answer. You know what is monolithic and microservice architecture,
I
right?
know monolithic.
What?
I know monolithic. I don't know what microservices.
Microservice is like you have decoupled architecture and
Mhm.
okay,
Oh, it is saying it's the exact opposite.
this is wrong. So what is this? So
Mm.
give the option that we selected the last one. Oh,
No, that's not the thing either.
okay, then I think all the options. What are the other options we have? Two or eliminate.
Domain
What the hell? I think none of the option is correct then.
requiring our assets to be pre-optimized for specific renderer. Payloads, lazy loading is one of the answers. Aggressive instancing, sparse composition, non-destructive layering. I think we did see one of the answer like this question before as well, and this was the option sparse composition.
Which one? Sparse composition.
Yeah,
Oh yeah, non-destructive layering. But
if an artist needs to change the color of single door, blah blah blah, they have a tiny kilobyte size layer that only contains new color. Hmm. Okay. 73%.
nice. Oh, we are done.
Yeah.
Nice.
Failed.
We have failed the exam. No worries. But dude, a lot of questions were wrong as well, so I won't take it.
Yeah.
Yeah.
All right, bro.
All
I
right.
think that's it for today. I will sleep early.
All right. Perfect. See you then.
End stream.
Is it ended?
Yeah.
Match the padi.